Good evening everybody, and once again welcome back to the channel. In today's video I want to show you how to run full text search / semantic search and ask question naturally against your data in Postgres. For this we will be leveraging a plugin called PgVector. PgVector allows you to run cosine similarity against your vector embeddings, right? So the best way to learn something is to try things out. So in this video, I'll show you an amazing hands-on lab. So if you have Docker and Python, let's rock and roll, guys. So the first step that we need is Postgres. Okay, we need a Postgres with PgVector installed. We're gonna be using this particular image, Ankana / PgVector. This image. The database name is going to be VectorDB, username, password, right? So the first step, come to the project repository, guys, and let's run docker compose up --build -d. This will start the container running locally. Now that we have our Postgres running locally, what we need to do next is basically we'll start up a Jupyter notebook and then we'll start executing some Python commands. Just a quick note, the embedding model that I'm using is a little bit old. You can always use OpenAI API. The reason I'm not using it because it will be a little expensive. For each document I have to call the API, which will convert into a vector. So I'm just using sentence transformer, but feel free to swap that particular block. All right. So step one, you have your Postgres running, right? Step two, download this sample dataset. This is a dataset that you can find on Kaggle. I just downloaded it. It's a sample job posting dataset. So what do we want to do here? So what we want to do is basically we have these jobs and I want to basically search through the jobs by asking questions naturally. Like, hey, I know Python and AWS. Can you recommend me some jobs? So I want to ask these questions naturally, right? So let's see. Again, simple. I'm importing OS, pandas, numpy, and a sentence transformer. Again, feel free to use OpenAPI as well if needed, okay? I have a very simple class called reader. The job of this class is to read the CSV file. It's gonna read the first 300 rows, okay? I have a class called tokenizer. The job of the tokenizer is to take the text and output an embedding, a vector, right? An array, right? That's basically it. So the first what we're gonna do is let's try this out, okay? So now we're gonna read the data set. We are reading the data set and there's a column called job post, which is a long job description. What we are doing is basically we are converting that into a vector. As you can see, this cell is now executing, as you can see. So let's wait a little bit for this to complete. So as you can see, I'm using a library called TQDM. What this allows you to do is it allows you to see a beautiful progress bar. So I can see how many documents I'm on currently, right? So hopefully that made sense. I'm only doing it for first 3000. Again, you can go and try for the entire data set. So let's wait for a couple of more minutes while this is complete. So this will take the job description, the lengthy job description, any text that you have, and it basically converts into a vector embedding. So let's see that. Should be done, almost there. Okay. All right, I'll do your df.head, which means I'm showing you the first two data set. Here you can see I have some title, this, that, and here you can see that vector. We have that long vector, right? Okay, so that's that. Now what we need to do is I will create a table in Postgres. These are the columns in Postgres. The important one that I want to show you is the column called vector, and the data type here is used as vector. Again, that's important. We have to use vector there, okay? Here you can give it anything like foo, bar, embeddings, etc. Doesn't matter, but the type has to be vector, okay? So let's go to PgAdmin. This is a client tool used to query your Postgres. I'll open that up. Servers, localhost, password is gonna be test pwd. I am connected. I'll go to VectorDB, I'll go to schema, and then inside that tables, I do not have one. So let's create this particular table. The table has been created. Now I will simply refresh this. Hey, you got this table called jobs here, huh? All right, so I can do here select star. There's nothing inside that. We have to ingest some data. Okay, I'll show you that in a second. Okay, now what we'll do is we'll insert this data into Postgres. Remember, in the pandas data frame we have a column called vector, which is a long vector, right? We're gonna insert all of this data into Postgres. So I have this function called insert data into table, right? So we'll simply execute this. So for each row in pandas data frame, I am calling that function and it's gonna insert some data into Postgres. At this point, data is being inserted into Postgres, and as you can see, if I can probably scroll a little bit here, it's a long text. So here you can see the vector, that massive huge vector that I showed you, and all the other columns, title, salary, etc. Hopefully made sense. So the documents have now been ingested into Postgres. Okay, now we can naturally ask question like, hey, I'm looking for this or I'm looking for that, and let's see how it works. Okay, so I made a function over here which does the cosine similarity. This is a function called find similar documents. It performs cosine similarity and returns the documents to you. So here what I do is the user will ask a question naturally, like, hey, I want to do this or that, and that text is converted into a vector, and then we perform cosine similarity and we return the most similar documents. Again, I only have 3,000 documents, so it's a pretty small data set. So let's see. I'm looking, I said I have experience in, probably Python and AWS. Can you suggest me or recommend me jobs? So as you can see, it gave me jobs for Python developer, software engineer, web systems, and group engineer. It's doing a pretty good job. You can also filter out documents by score and say, hey, only give me documents where the score is greater than 65% or 0.65, right? Hopefully made sense, right? And last but not the least, I was able to learn this from this particular Medium blog. I like to read a lot during my free time. I read a lot of blogs, right? So thanks to this guy who wrote this amazing blog post. So yeah, it's literally that easy. All you need is a bunch of text, right? If you have a bunch of text, use model, convert your text into embedding, and then naturally run queries against that. That's simple as that. You can also use, so for the vector data store, you can use Postgres. There's a plugin called PgVector. You can use Pinecone, and you can also use Elasticsearch. These all three, they work, right? So that being said, the entire Jupyter notebook is there on my blog post with the example data set. So all you need to do is just spin up Docker Compose your Postgres with the extension PgVector, and then you can run this exercise or lab. Try this out. It's really, really amazing. Better than writing query, hey, select everything from this particular table where it's like something. Instead of running those like query, which doesn't really work, this is a much better way to naturally ask and get documents in return. That's all I have, guys. Thank you so much for watching the video. If you have any further questions, let me know. Of course, once you get the document, you can run through a ranking system. You can rank the documents, all of that. You can, of course, explore, but I just want to make it simple, easy, a blueprint for anybody who's just watching this particular video. Thank you, and I hope you have enjoyed. I hope you're safe. I hope you're healthy. With that being said, keep smiling, keep programming, keep learning, and I'll see you in the next video.